Okay, if you only have a half cup measuring cup, if you only have a half cup measuring cup, and a recipe calls for 2.5 cups of flour, how many half cups would you need to use? How many half cups would you need to use? How are we going to do this question? You see that they're asking us how many half cups are in 2.5 cups. That's what they're really saying, aren't they? How many half cups are in 2.5 cups? That's what they're really asking us. How many half cups in there? Right? How many times are we going to, how many half cups would you need to use? How many half cups are in 2.5 cups? Is that an adding, subtracting, multiplying, or dividing question? What do you think? Adding, subtracting, multiplying, or dividing question?
I want to say it's dividing.
Yeah, it's got to be dividing, right? Because whenever you say how many of one thing fits into another, that's dividing, isn't it? If I said how many 2 cups fit into 10 cups? Well, we would go 10 divided by 2 equals 5, wouldn't we? So it's the same thing with these fractions, isn't it? You start with the bigger one, 2.5, and you divide by the smaller one. Right? Everybody with me there? Let me go back. So you take the bigger one, 2.5, and you divide by the smaller one. Okay, so how do I work out that problem? How do you divide mixed numbers? Maybe this would be a good time for me to write some instructions for that. Let's do that over on the side. So we've already added, subtracted mixed numbers. Let me just remind you, when you add or subtract mixed numbers, step 1, you get common denom, right? You got to have common denom. And step 2, you, what did I want to say? You get a common, well, let me move on. Sorry, I'm kind of forgetting what I wanted to say. There's something important. It'll come to me in a minute. Let me come down here to multiply, divide. When you want to multiply or divide mixed numbers, first off, number 1, common, no common denominator is required. Do you remember that? You're not required, just like in last night's homework, right? When you're multiplying, dividing fractions, normal fractions or mixed numbers, it doesn't matter. No common denominator is required. You don't have to get a common denominator. It's just not needed. Okay, so that's not required. Oh, and then so what do you have to do? Here's what I want to say. You must change to improper. That's the crucial fact. You must change to improper. Whereas up here for mixed numbers, when you're adding, subtracting, you do not, well, how about I just say you can leave them mixed. You can leave as mixed. You can leave them as mixed. So yeah, so you can just leave them as mixed when you're adding, subtracting. So you want to get those down if you're not already 100% clear on that. There are some different situations for adding, subtracting. So for adding, subtracting mixed, you have to get a common denominator and you can just leave them as mixed. But when you're multiplying, dividing, No common denominator is required, but you must change them to improper. That's the most important part of this whole thing. So first step here, I'm going to say we must change to improper. So step number one, we must change. So step number one, we must change to improper. So how do we do that? So you multiply and add, right? So 2 times 2 is 4, add 1 is 5/2 divided by, and then the half is just stays as it is. So is that good? Step number one, you must change to improper. You cannot leave them as a mixed number when you're multiplying and dividing. You have to change them to improper. Step two, how do we divide two fractions? Now they're just normal fractions, aren't they? Oh, what did I do? I just keep hitting the wrong button here. Sorry, I don't know why I'm keep hitting the wrong button 27 million times here. Let me go find it. What was it called? Like, sorry, I know it looks the same on your screen. Let me find it for a second. Okay, so now that we've changed it, oh, no, it's the wrong one. Sorry. Let me grab it. There we go. I think I've got it. All right, I'm back. Okay. Yeah. So what do we do here? How are we going? What are we going to do now to divide these? Yeah, remember from the video, at least that's what I call it. Keep, change, flip. Keep, change, flip. So I keep the first one the same. 5/2, right? Let me get rid of that there. So 5/2, keep that first one the same. Change to division to multiplication and flip the one on the right. Is everybody good there? Remember that? That's how we handle dividing two fractions. I call it keep, change, flip. You can call it whatever you want. Basically, we do that. Now, why? I'm into always showing you the reason why, because I want you to see math is not a bunch of tricks. Math is truth in motion. Why is that true? Well, if you watched my videos from last night's homework, you probably got tired of me doing over and over again, which I'm going to do one more time, sorry. 10 divided by 2 is 5, and 10 times a half is also 5, right? Half of 10 is 5, just like 10 divided by 2 is 5. Those are the same thing, aren't they? So my point is, and you know that, this is like, we know that, I'm saying we already got that right. So look at what that means. That means dividing by 2 is the same as multiplying by a half. So in other words, dividing by a number is the same as multiplying by the upside down, isn't it? Dividing and multiplying are just upside down operations. That's why this is true. You already know that. Just observe these facts, which you already knew. They prove that dividing and multiplying are just upside down operations. That's why this is right. When you change from dividing to multiplying, you have to flip the one on the right. They're just upside down operations. Okay, so with that in mind, let's finish the question now. How do we finish this question? Well, there's two ways you can do it. You can take 5/2 times 2/1, and you can cross multiply. That would, or sorry, not cross multiply, cross cancel. That's a little quicker. You can just go boom, boom. And so then the answer is 5/1 or just 5. The answer is 5. Or you can multiply straight. You can multiply straight. So you can go 5/2 times 2/1. This is the other way. You can just multiply straight. 5 times 2, 2 times 1, 10/2. It's going to end up being 5 in the end, either way, right? Cross cancels a little quicker because it just cancels these out right away, and you just go straight to the 5. But you can go multiply straight on the top and the bottom if you want to, and then just reduce at the end. So cross canceling is really just early reduction. That's all it is. I don't want you to think cross canceling is some other different fancy trick. It's not. It's just reduction, right? You know you can reduce fractions top and bottom. You can reduce fractions top and bottom whether they're straight up and down or diagonal. It doesn't matter. This is just diagonal reduction. That's all it is. You're just reducing early instead of reducing late. It's all the same thing. So the answer is 5 either way you go. Questions on that one? So that makes sense? So the moral of the story here is that when you multiply, divide, mix numbers, you must change to improper. You must change to improper. So I had to change to 5/2 to do the problem. And then, of course, you dividing becomes multiplying, keep change, flip the one on the right, finish up the problem. There we go.